So this is about finding the some measures of center, mean, median, mode for a frequency distribution. I'm looking at the eruption times of the Old Faithful geyser. There were 299 eruptions, but we don't have a list of all of them. We don't have the raw data. See, I've only got like about 39 numbers here. I don't have 299 numbers. Because what I've got is frequencies. There were 5 eruptions belonging to this class here. I use the word bin because that's the term that Microsoft uses for the upper boundary of a class. I use the histogram tool to make a histogram of this data. So you see this class labeled 1.6. It has a frequency of 5, so there were 5 eruptions in that class. Now, that doesn't mean that those eruptions lasted exactly 1.6 minutes, because looking over here, see that the class width is 0.2 minutes, and so if an eruption lasted anywhere between 1.4 and 1.6 minutes, it would belong to this class. Okay, these are the upper boundaries of the class. And so we have 5 eruptions. Probably none of them were exactly 1.6. All we know is that they were close to 1.5. That's the class mark. That's the middle of the bar. It's halfway between 1.4 and 1.6. So we have 5 eruptions that were just about 1.5 minutes long, and 26 eruptions that were just about 1.7 minutes long. So if you were to turn this frequency table into raw data, you'd say 1.5, 1.5, 1.5, 1.5, 1.5. Then 1.7, 1.7, well, 26 of those. So you'd make a big list of 299 data items that you could then find the mean of, find the average. But an easier way to do this here's what I want to do. I want to take I got 5 1.5s, so I'll say 5 times 1.5. And then I'll say 26 times 1.7, and 45 times 1.9. Just add all that up and divide by the 299. So let me put that, sort of type that or I'll write it as a formula on the graph paper. So for raw data, if I had a list of all the individual x values, I add them up, divide by how many there are. Simple. So this time I'm going to add up for, not for all the individuals, but for all the classes. So the little m here is the number of classes, like maybe you got from Sturgis's rule to decide how many bars to put in your histogram. Just to compare the formulas, like in the first one, xi was the x value of individual number I. But down here, the fj, it's the frequency of class J. And the xj is the class mark of class J. So that's how you find the mean. And then to find the mode for a continuous variable, it's the midpoint of the tallest bar in the histogram. So this bar here has a height of 54. So where is it in the table here? It's this one. Let me get back over where you can see. So the tallest bar in the histogram here has a frequency of 54. It's this bar here. It includes individual eruptions that lasted between 4.4 and 4.6 minutes. So the class mark there is 4.5 minutes. So the mode is 4.5 minutes. And then there's a minor mode over here at the middle of this class, 1.9 minutes. So Old Faithful has two modes of eruption. It's a French word, mode. It's like the style, right? You know, like pie a la mode. I used to think that was pie with ice cream, but it's pie in the style, the fashionable pie. Okay, so a mode of 4.5. It's got, Old Faithful has sort of two ways of erupting, two modes of eruption, two styles. There's the long ones that last about 4.5 minutes, and then there's the short ones that last about 1.9 minutes. And so the modes are the numbers of minutes there. It's the x value. All right. Okay, so I think, let me end the recording for that.